Hi, welcome to the Anthos Deep Dive. This will be part one of a two-part session. My name is Vic Iglesias. I'm a product manager with Google, and I have with me my colleague.
I'm John Murray. I'm also a product manager at Google.
So let's dive in. First thing you need to know about Anthos is that Anthos doesn't just target one persona within your organization. There are many personas that can benefit from onboarding onto Anthos and its technologies, including the infrastructure operators, the service operators, and the developers. And for those folks, there's going to be a lot of different benefits. Could be that you're looking for consistency in the way that you manage your infrastructure and applications. You might be looking to put security guardrails in place to make sure that your developers have the autonomy they need. And we'll walk through some of these benefits as we go through the talk. When we're talking about Anthos, we really talk about these five main components. And today we're going to talk about the bottom three here. So we'll talk about Anthos GKE, Anthos config management, and cloud logging and monitoring. So these are really targeted at the infrastructure operators. And in part one, we'll focus here. And you'll see service operators and developers and how they can benefit from Anthos in part two. So first, let's talk about Anthos GKE and why customers choose GKE in general. And we break this down into four parts. First, it's really easy to start. And this is a lot of the ways that people get started with Kubernetes in general. You've got a really intuitive console that you can use. You've got CLIs that provide the functionality that you need in order to get up and running and scale your services. And you can do this all in one click or in one command and really have a lot of the ongoing management handled by our GKE SREs. So with that simplified management, what do we really mean? Well, you get inbuilt monitoring for all your Kubernetes clusters, whether they live on-prem or in other cloud providers. You can hook those all in and have all of the monitoring and metrics show up in a single pane of glass interface within the Google Cloud Console. So this is super helpful for wrangling all the clusters that you might have and all the workloads that you have across your organization. Next, we have features like release channels, which help you with the ongoing maintenance that you might have with your Kubernetes clusters. For example, upgrading. You might not want to always upgrade to the latest version, or you might want to upgrade to the latest version because it has a feature that you're looking for. And so what we have in these channels is the ability to pin to a stream of releases. So for example, if you're looking for always the latest release, you can pin to the rapid channel, and that'll give you the release of Kubernetes that we've vetted most recently. Some customers want to have more stable releases that we know have worked well over time, and they can pin to the stable channel, which will give them a slower upgrade cadence. For folks that are somewhere in between, you can pick our regular channel and get the updates as they've been vetted by folks in the rapid channel, and then we'll finally pass on into the stable channel. So with features like that, really we're optimizing for ease of management, but we also optimize for different types of workloads, right? So if you have machine learning workloads or really intensive data programs that you're running on your GKE clusters, you might need some hardware accelerators in order to enable those to run at the highest performance. So with that, we have the ability to attach GPUs, TPUs, and local SSD to your GKE nodes, all through the declarative Kubernetes configuration in a really simple way to optimize those workloads for you. Additionally, we want to make sure that you can run both your Linux and Windows workloads in the same cluster. So with this, we have support for Windows Server containers, and they will just show up right side by side in the same interfaces that I've shown before with the same monitoring and metrics, all in the same cluster. So really useful for those mixed workloads. As you're thinking about scaling up the amount of workloads that you have in your Kubernetes environment, you're going to want to make sure that your clusters scale really well and that your workloads scale really well. So one way we've helped with scaling your workloads is to implement cloud-native load balancing. With cloud-native load balancing, you can avoid a second hop for your requests coming from the outside world through load balancers and go directly to your pods. So now, not only is there one less place where you can have a single point of failure for your workloads, but also you're getting to your workloads with the least latency possible. Additionally, we also think about how you might scale up or scale out your workloads in GKE. So, for example, you might use vertical pod autoscaling. When you have a workload that can't really scale horizontally, but needs to scale vertically, and you don't really understand how much CPU or memory it might use, you can use vertical pod autoscaling in order to watch that workload. And as it reaches the limits of what it needs, if it's available in the cluster, it'll automatically get those resources allocated to it so that it can keep running and won't crash or move to another node. These are the kinds of features that make running workloads in GKE simple as possible. Additionally, if you don't want to think about what size your nodes should be for your GKE clusters, you can use the node auto provisioner, which will just provision the right size nodes for the workloads that you've asked from your API server. And finally, another way we've helped with scaling Kubernetes to make sure that clusters scale to a large number of nodes. And recently we announced that we can scale up to 15,000 nodes with a single GKE cluster. So all this is to say that customers choose GKE because we continue to innovate on your behalf. And this is something that we are constantly working on and working with our top customers to make sure that their needs are met and that those can be used in the simplest possible way for other users. We understand, though, that not everyone can run on GCP for various reasons. So we want to make sure that you can run Anthos and Anthos GKE in any place where you want to run a Kubernetes cluster. So with that, we'll start talking about Anthos GKE on-prem. And really, when you think about on-prem deployment options, you might ask yourself, why do customers need this? Well, one example might be that they have a database somewhere inside of their data center, and they want to have that workload as close to the database as possible. So they want to have that Kubernetes cluster inside their data center. Another reason might be that they have data locality restrictions, and they have to have a cluster in a particular place, and GCP doesn't have a region there. So for these types of use cases, we have Anthos GKE on-prem, which will allow you to deploy Kubernetes clusters inside your data center. And we'll walk through a high-level architecture of how Anthos GKE on-prem works. So first, when you're trying to get Anthos GKE on-prem installed, you'll point your laptop or a developer workstation at a vSphere API inside your data center. That vSphere API will then provision what we call the admin workstation. And this is a Linux machine that bundles all of the utilities and binaries that we need in order to deploy the rest of the architecture. So this is really kind of the seed node for the rest of what we'll talk about. Once you have that admin workstation stood up, you're going to deploy the admin cluster. And the admin cluster is the control plane that allows you to create many user clusters. And those user clusters are the ones that we're going to hand over to the end users of Kubernetes. This admin cluster makes sure that the right number of nodes is provisioned, that the right plugins are installed into your clusters, that the right functionality is available to your end users, and we'll make sure that that state stays up to date. So once you have that admin cluster, or that control plane up and running, you can start to create user clusters. And that is done by creating a Kubernetes resource and applying that into the admin cluster. Once you do that, the admin cluster will look at the configuration that you've asked for as far as what that cluster should have in it, what the size should be, how many nodes it should have, and it will go ahead and provision that user cluster for you. And then you can get some credentials out of there and hand them back to your users. This can create up to 10 user clusters per GKE on-prem installation, and each of those 10 user clusters can have 100 nodes. So this really allows you to scale to a large number of Kubernetes clusters within each data center footprint, and then provide those to various use cases within your organization. Once you have those user clusters and the control plane up and running, you'll also want to include load balancing. And load balancing gets traffic into your workloads. So the types of load balancers that we have available today are one inbuilt load balancer, which is what we recommend. This is based on some Google technology that we provide L3 load balancing on behalf of the clusters. You could also bring an F5 big IP if that was how you were doing the load balancing in your organization. Or you could bring your own load balancer that was not fully integrated by us and configure that to point at your user clusters and your admin control plane. So a lot of flexibility there to get the right setup that you need. On-prem is one of the places where we think about clusters being required, but we also know that you have other clouds that you've been committed to and have workloads running in. So we want to make sure that you can run Anthos GKE on any of the other cloud providers. The next thing we'll talk about is Anthos GKE on AWS. There's a lot of benefits to having Anthos GKE on AWS. One is you get all the functionality that I talked about in the earlier part of the talk, where we're managing clusters for you, we're integrating monitoring, those pieces. And really, it allows you to integrate that functionality into your existing AWS footprint. So super useful stuff. The pattern with Anthos GKE on AWS is that you'll have a jump host, similar to how we had the user laptop in the Anthos GKE on-prem example. And that jump host will have a binary on it called Anthos GKE. And that binary will talk to the EC2 API and provision, again, an admin cluster, which will act as your control plane for other clusters that then you provide to your users. So once you've provisioned that admin cluster, you're going to go ahead and run commands against it to provision your user clusters. Again, the same pattern that we had before. What we do get as a benefit by running inside of AWS is we have an inbuilt load balancer in Elastic Load Balancing, ELB, that comes out of the box. So you don't have to configure or run your own load balancer in that case. As far as features that are available in Anthos GKE on AWS, you have the ability to have HA control planes, auto scaling, in-place upgrades, and your storage backed by AWS's EBS. If you don't have an existing VPC and want to just kick the tires, you could absolutely create your own VPC through the Anthos GKE on AWS installer, or you can choose to install into an existing VPC. And all of these clusters that you bring up are going to be well integrated with Anthos config management, Anthos service management, and Cloud Run on Anthos, which we'll talk about in part 2 of this talk. So now that we have clusters all over the place, how are we going to manage all the workloads across them? How are we going to make sure that they are as uniform as possible, that we know what's running? Well, we're going to have some challenges there, and Anthos is willing to help you here. So we know that users have a lot of different multi-cluster use cases. We talked about some around data locality, being near to databases, but you also might want to have highly available services. You might have different environments that have different clusters. And you might have, for example, a low latency service that you want to have with clusters that are in different regions. So the first thing that you might want to do, since if you're already a Kubernetes user, is attach a cluster to Anthos that you've already provisioned somewhere through some other mechanism. And we allow that. So you can bring your own clusters to Anthos, no matter how they were provisioned, as long as they're compliant Kubernetes clusters. So the way that you do that is you would register them through the Google Cloud Console or via the CLI, and that would attach them to our Anthos control plane. The way that that actually works is that we have an agent that runs inside of your cluster, and that calls out of your cluster and connects to our control plane in a secure manner. It actually encrypts that connection that's egressing your environment and makes sure that it's secure. And then with that connection nailed up, we can start to do higher order things like provide load balancing across clusters, or just show you your workloads running for those clusters inside of the Google Cloud Console. Another thing that you get out of attaching these clusters is you get to start turning on and off features that you might want to have using Anthos. So for example, you might want to turn on Anthos config management, which we'll talk about in the last half of this talk. You might want to set up load balancing across the clusters, and you can do all of that through the Anthos UI. Once they're attached, they're going to show up just like any other GKE on GCP cluster. So you'll have those listed here. You'll be able to see which ones should be upgraded, what the capacity of those clusters is, and whether they're healthy. So super useful stuff. So we can talk about multi-cluster ingress. Multi-cluster ingress allows us to have a single load balancer IP that can point to multiple clusters within our Anthos deployment. So now I can route people based on the lowest latency cluster that would reach them. And if I have a failover scenario, I can route to an additional cluster that may be in a different region or a different zone, or maybe in a data center. So with these features, we're really trying to make sure that Anthos has the ability to bring to you higher complex use cases in a really simple way that maps to how we do things in the Kubernetes world. And with that, we're going to go ahead and take a look at how these things fit together through the Cloud Console. And we're going to look at how we manage our clusters from GKE on GCP, GKE on AWS, and GKE on-prem. All right, Since we now seen how Anthos can get us clusters provisioned, and we've seen some of the methodologies for how that's done, let's take a look at what we end up with when we put all of these things together. And we'll explore this using the GCP console. So here we are on the home page. I'm going to go ahead and click on the hamburger menu over here and then down to Anthos. The Anthos dashboard is meant to tell you your cluster status, what features you have enabled on each of those clusters. We can see here that we have 6 clusters currently in Anthos management. And we'll see here that some of them are provided by vSphere. So this is our GKE on-prem cluster. We also have some in US Central within GCP, US East within GCP, and then also one registered with Anthos from AWS. You can see all these clusters show up in the same place. And we can also check on the current status of their configurations to make sure that they're synced to the GitOps configuration that we've put into our repository. We can see that all from the Anthos dashboard here. But if we go into the Kubernetes dashboard, we can actually see some deeper insights into what's running in our clusters at this time. So here we have the list of all of our clusters. We can see that we have clusters again in GCP, AWS, and vSphere, and they all show up in the same pane of glass here. We're going to go over and look at our workloads. So this can be used as a UI for Kubernetes. So here I have a saved faceted view for my dope app. This is an application that's running across a bunch of different clusters. So we can see here that I have some running inside of my production clusters, some in my staging clusters, and some on my dev clusters on-prem. So you can see all of these in a single pane of glass. And when I click into these workloads, I can actually start to see some of the monitoring and metrics of how they're operating. So you can have this as a developer portal as well, so they can help debug. I can also see the events that might have been fired for this particular workload. And I can go ahead and look at my services that were provisioned in here. So a lot of functionality that can be found for any of your clusters that are registered with Anthos. The other thing that you might want to do is check out your logs and have an integrated logging view. So with that, we have the logs view, where you can filter on a bunch of different things, including the container type, the cluster, or a particular Kubernetes node if that's giving you trouble. So if we click on Kubernetes cluster, we can see these are the logs from our clusters that are registered in GCP. And we can see all of the information about the resources that have been applied. We can also go ahead and click into a particular container workload and see the faceted view of where those are running. So here we can see the clusters. I can click on, for example, my on-prem dev cluster, and I can see all the logs for my workloads running there. I can then filter that down, for example, by namespace. So I might click into the kube system namespace because something isn't quite running right, and I can start to see all of the information about things that are going wrong there. Next, I wanted to show how I might add a namespace to all of my clusters. Since I have the ability to manage these clusters in a uniform way, how might I add a particular namespace? All right, so here we have a Git repository that contains all the configuration that we want shared across our clusters. So for example, if I wanted to add a namespace, I could go to the namespaces folder and add a file in here that has some Kubernetes manifests that I'd want added. So I'm going to go ahead and add a new file here. And I'm going to call it namespaces/myawesome. And in that, I'm going to create a namespace.yaml. I'm actually going to overload this a little bit, and I'm going to also include not just the namespace definition, but actually a pod. And so we'll see my namespace get created, which is going to be called my awesome app. And we're going to have a pod created, which is going to be this web server pod. So we should see when we go back to the console that these are all showing up in our clusters. So let's go ahead and commit these. Now, when you commit these changes, they can be reviewed by folks. You can have a transaction log of all these changes that have gone through, just like any other Git repo. So let's go take a look at what this looks like inside of our console. So I go back to my Kubernetes engine clusters here. And now I should be able to see and filter on my namespace that I just created and see those pods coming up with that web server enabled. So let's see here. Okay, I see that I have all my clusters here. I go to the workloads pane, which is going to contain all the workloads in all my clusters. And I'm going to go ahead and reset this one, which was for my previous application I was using. And I'm going to look for my new app called My Awesome App. Great. So we can see here, we've already got some of these coming up. So we have a prod West cluster that's running our pod and our dev on-prem cluster. So that's it. We've got things running. And now we'll hand it off to John, who's going to take us through a little bit more in detail of what ACM, Anthos Config Management, can provide.
Thanks, Vic. I'm going to talk a little bit about Anthos Config Management. Anthos Config Management helps you manage all of your configuration and policies at scale and includes 3 different components. There's Config Sync for managing configuration, Policy Controller for managing your governance and compliance policies, and Config Connector for bringing GCP into Anthos. First, let's talk about Config Sync and how it helps you manage configuration at scale. So when you've got a large and diverse hybrid environment that runs on Kubernetes, you have a couple of scale problems. One is scaling your team. You've got many people on the operator team who need to apply configuration changes to that environment, whether it's on GCP, on-prem, or in other public clouds. And as that team grows, making changes against that environment by running commands through kubectl becomes harder and harder to keep straight. You don't know who's doing what, and you don't necessarily have a record of things that have changed. On the flip side, all of those clusters and all of the different teams sharing them get bigger and more diverse in multiple locations, and it makes it harder and harder to roll out changes that affect the entire environment. So the way we deal with that in Anthos Config Management is through a tool called Config Sync that puts all of your configuration in a centralized policy repository that's based on Git. And that means everybody in the operating team can collaborate together using methods that they typically use for application development, pull requests, and code reviews. And that helps your team work better together. And then by connecting that multi-platform environment back to that central repository, it helps your environment work better by having a single centralized source of truth for all of your configuration. Config management stores that configuration in a secure repository and then rolls it out to all of your Kubernetes clusters and to Anthos Service Mesh. And that means all of your configuration is auditable, that there's a record of every change that's made to the environment stored in that Git repository. It's revertible in terms of being able to roll back to the last best good state. It's transactional, and that changes can be grouped together and rolled out all at once. And it's self-healing. That single source of truth is kept in sync with all of your clusters, and any local changes are guarded against drift so that you can be assured that it is applied everywhere. How that looks in a production environment might be something like this. So if you have Google Cloud Platform with a GKE cluster running on the left and an on-prem data center that's running GKE prem on the right, you can connect those through Cloud Interconnect and have a single common private network. The policy repository that holds all of your configuration can live on-prem or it can live in GCP. In this case, it's running on-prem, and that policy repository allows you to define your configuration using abstract namespaces for inheriting configuration across multiple teams, so you can define policies that apply globally. In addition to that, you can specify configuration should be rolled out to a single cluster or a set of clusters when you need to configure things differently. Now let's talk about managing policies at scale with Policy Controller. Policy Controller is included in Anthos Config Management, and it is based on the Open Policy Agent Gatekeeper project in open source. It allows you to manage policy at multiple stages of config deployment. And so you can inspect configuration before it gets applied. You can enforce policies at the API layer, inspecting every call that comes into your Kubernetes environment. And then you can run audits using the same policies to look at historical changes or simply just to inspect things without necessarily enforcing them actively. And that means that any client that is connected to your clusters is respecting the guardrails that you have in place that enact your security and compliance policies. Those policies are diverse, and that's why we support custom policies in Policy Controller. The Policy Controller also comes with a default policy library, and that includes 27 constraint templates that are used for common use cases that we see all the time with our customers. And these are policies that are maintained by Google and included as part of the distribution. That might be something like restricting a role binding to only your corporate domain, or ensuring that mutual TLS is turned on so that all of the traffic running over your service mesh is encrypted in transit at all times. Finally, let's talk about managing GCP resources as part of Anthos. GCP Config Connector is designed to expose all of the popular GCP services that our customers use as part of Kubernetes and Anthos. It does that by taking every popular GCP API and turning it into a Kubernetes API, so that when you're deploying applications through kube control, through a Git-based deployment like config management, or through API clients, you can treat GCP as though it were just another part of that Kubernetes environment. That means you've got a native API service for GCP, and you can specify the resources that you would like that underlie your applications, whether that's a database or a storage bucket, in declarative configuration. And that configuration will be continuously reconciled against the cloud and guarded against drift. This is available now, and it is included as part of Anthos Config Manager. So all of these components can be installed separately, but they can all be used together. And that means you can store all of your configuration, whether it's Kubernetes, Service Mesh, or GCP, in a single common Git repository. Roll that out and check it for policies that ensure that it's compliant with your security rules and your operational controls, and extend that way of managing configuration from Kubernetes all the way to GCP. And that's Anthos Config Management. That concludes part 1 of our deep dive. Stay tuned for part 2, where we'll talk about Cloud Run for Anthos and Anthos Service Mesh. On behalf of Vic and myself and all of Google Cloud, thanks for joining us today.